Hi, everybody. We are going to be going over solving systems of linear inequalities. So, we're going to be taking what we learned with our systems of equations, and we are going to decide if we can graph two inequalities, linear inequalities, and see if we can find a solution area, or even be given a point and decide if it's a part of the solution for the inequality. So first we have to remember, what is an inequality? Inequalities have the less than symbol. We remember doing this, a less than or equal to. And then we also have the greater than or greater than or equal to symbols. So we did these a few weeks ago. And so we are going to be looking at a system of linear inequalities, which is a set of two or more inequalities containing two or more variables or letters, so x and y. The solutions of a system of linear inequalities consist of all of the ordered pairs, so x's and y's, coordinate pairs, that satisfy all of the linear inequalities in the system. So if I have a coordinate, as I do in examples 1 and 2, those coordinates need to work for both inequalities. It has to work for both, otherwise it doesn't work at all. And so for these first two examples, I'm just going to have to plug these in. I have -1 and -3 for my x and y value for example 1. So I'm going to take my first equation and I'll write them separately. I've got y is less than or equal to -3x minus 3. And my dogs are starting to fight, so I'm sorry if they get a little loud. And I'm going to plug in x and y for that problem. So I'm going to take everywhere I see y, I'm going to replace it with -3. Ooh, that ink is a little large. So -3 is less than or equal to -3x. So I'm going to do a parentheses, -1 minus 3. So we have -3 is less than or equal to -3 times -1 makes a +3 minus 3. And then we bring everything down. 3 minus 3 is 0. So we have to ask ourselves, is this true? Is -3 less than or equal to 0? And yes. So far that works. But then we have to do this again for the second equation. So I'm going to take the second equation, which is y is less than 2x plus 2. And I'm going to plug in x and y again. So we have -3 is less than 2 times x, so 2 times -1 plus 2. -3 is less than 2 times -1 is -2 plus 2. -3 is less than -2 plus 2 is 0. So it is saying -3 is less than 0. That is also true. So we are going to say, yes, this is a solution. So yes, -1, -3 is a solution. And I'm just going to say SOL for solution. Okay, so for example 2, we're going to do the same process. And we have our x value, -1, and our y value, 5. So again, we are going to take those and plug them in. I'm going to look at my first equation, which is y is less than -2x minus 1. And plug in the x and y values. So the y is 5. So 5 is less than -2 parentheses x, which is -1 minus 1. 5 is less than -2 times -1 is a +2 minus 1. And then it finally says 5 is less than 2 minus 1 is 1. So again, we ask ourselves, is it true? Is 5 less than 1? No. And as soon as you get a no, the answer is just no. Both systems, both equations, I should say, or both inequalities have to work in order for this to work. So the answer is no, not a solution. So -1, 5 does not work for this situation. I don't even have to check the second equation. I only check the second inequality or equation if the first one is a yes.